In this video lecture, I will explain null NFA to NFA conversion. So what is null NFA? It is possible for a machine to change its state from one state to another state without giving any input. So in this diagram, you can see we have three states Q0, Q1 and Q2, where Q0 is the start state, Q1 is the intermediate state and Q2 is the final state. And there are three input alphabets A, B and C. So if a machine is in state Q0, if input A is given, it remains in the same state, and there is a transition from Q0 to Q1 for Epsilon. And if machine is in state Q1 and input B is given, it remains in the same state, and transition from Q1 to Q2 for input no input, or we can say Epsilon. And if the machine is in Q2 and input C is given, it remains in the same state. So for null NFA to NFA conversion, what you need to do, you need to just remove all the null transitions. Okay, so first step will be, we need to find the null closure of all the states. And to find the null closure, we know what is null closure. So if I say the state Q0, the null closure of state Q0 will be set of all those states which can be reached from Q0 using null moves. Similarly, if I say for Q1, so set of all those states which can be reached from Q1 using null move. And for null closure of Q2 will be set of all those states which can be reached from Q2 using null move. So first step should be finding the null closure of all the states. So Q0, you can see here in this example, Q0, and one more thing, any state can null, if I am calculating the null closure of the state, so that state is always going to come, means null closure of Q0 will be Q0 definitely, because what is the meaning of null closure? The state which can be reached from Q0 using null move. So if machine is in Q0, null move means we are not giving any input. So definitely if the machine is in some particular state and we are not giving any input, machine remains in the same state. Okay, so the null closure of that state will be the state itself always. So Q0, null closure of Q0 will be Q0. And then from Q0 I can reach to Q1 using null move. So Q1 is also going to come, and from Q1 we are going to reach to Q2 using null move. So Q2 is also going to come. Now if I find null closure of Q1, so Q1 is going to come, and then from Q1 I can reach to Q2 using null move. So Q2 is also going to come. And if I am calculating the null closure of Q2, so that state will come Q2, and then any other state Q0 and Q1 cannot be reached from Q2 using null move. So only Q2 will come. So first step will be find the null closure of all the states. And then this equation you should remember, and using this equation we are going to find the transition function for NFA. So here we are just denoting it by delta dash, and QIX, where QI is the state, the current state of the machine for which we want to find the transition, and X will be the input. So here you can see A, B, C, there are three input. So if I say Q0 is the state, current state of the machine, so X first for input A will be finding the transition function, then for input B, and for input C. So from Q0 I will be finding the transition function for input A, B and C one by one. So when I say Qi is nothing but Q0, so here in this equation, when I say Qi is nothing but Q0 and X is nothing but the first input, that is A. So here in this equation we have to just substitute Qi and X value. So null closure of delta of null closure of Qi. So here this bracket is very important. You should not change the order of the bracket. So here first this should be calculated, null closure of Qi. Null closure of Qi is what? Null closure of nothing but null closure of Q0. And what is null closure of Q0? Null closure of Q0 is Q0, Q1 and Q2. So that's what we have written. And then after calculating null closure of Qi, we have to find the transition function of that state with the input given here. So input is A considered. So here it will be delta of Q0, Q1, Q2, A. And if there are more than one states, how to find the transition function? It will be nothing but delta of Q0 A union delta of Q1 A union delta of Q2 A. And what is delta of Q0 A? It is Q0 only. From Q1 A there is no transition, so it will be 5. And from Q2 also there is no transition for input A. This also will be 5. So it will be only Q0. And then at the end, whatever result we get here, this whole thing we have to find the null closure of that. So the null closure of Q0 is again Q0, Q1 and Q2. So here we need to write Q0, Q1, Q2. Okay. And in the next step, what we have to do? We have to find the next transition, that is delta dash Q naught A we have calculated, delta dash Q naught B. So this is the formula, or we can say the equation which we have seen. It's kind of formula. So null closure of delta of null closure of, so the equation is basically null closure of delta of null closure of Qi comma X. Okay, so first we need to find the null closure of Qi. So here this is nothing but Qi, this is nothing but X. So Q, in place of Qi we need to write Q0, and in place of X we need to write B. And then null closure of Q0 was Q0, Q1, Q2. Here you can see Q0, Q1 and Q2. And then Q0, Q1, Q2, B, we have to find the transition function. So Q0 A B is phi, Q1 B is Q1, and Q2 B is also phi, because from Q0 and Q2 there is no transition for input B. So it is going to be only Q1, and then we will be finding the, once we calculate this bracket, we will be finding the null closure of that. So null closure of Q1 will be Q1 and Q2. So next here we have to write Q1, we have to write Q1 Q2. Okay, so we have to write Q1 Q2. So you can see here null NFA, we have null moves also. So basically the purpose of conversion of this conversion null NFA to NFA is just to remove the null moves. So same way we'll be calculating delta dash Q naught C, and that result we are going to write here. So you can see in the transition table, and this will be the transition table for NFA. This is NFA transition table, so it will not have any null move. Okay, so same way the next thing will be delta dash Q naught C. Same way we can calculate here the null closure of, here in place of Qi, Q naught will come because this is Qi, and in place of X, C will come. So this is X value, and then null closure of Q naught is again Q naught, Q1 and Q2, and Q naught C, there is no transition, Q1 C, there is no transition, Q2 C, it is only Q2. So only Q2 will come. So and then finally we will be calculating the null closure of Q2, that will be only Q2. So here we are going to write Q2. Okay, here we are going to write Q2, and then same way we'll be calculating delta dash, we'll be calculating delta dash Q1A, Q1B and delta dash Q1C, and delta dash Q2A, Q2B and Q2C, and these values we are going to write here. And then here you can see the start state is Q0. So Q0 will be the start state in NFA, and Q2 is the final state of null NFA. Same, Q2 will be the final state of null NFA. So the same thing is written here. Q0 is the start state, and this 3 we have calculated already. This also same way we can calculate, and Q2 will become the final state. Okay. So once you get the NFA from the equivalent, from null NFA you get the equivalent NFA. From NFA you can find the DFA also. So if null NFA to DFA conversion is asked, so first what you can do, you can write the corresponding NFA from null NFA using this procedure, and then from NFA to DFA either subset construction method or lazy creation of state method, which I have already discussed in my previous video. You can find the equivalent DFA also from null NFA. So hope you have understood the concept of null NFA to NFA conversion. Thank you for watching.